So good morning and welcome to the Low Carbon Concrete in Ontario webinar. It's a very exciting and important topic for our industry, and we're definitely excited to showcase how far we've come over the last few years. My name is Alen Keri. I'm the Director of Technical Services at Concrete Ontario. I have over 15 years experience in the industry, everything from dealing with specifiers, architects, owners, to doing mixed designs and mixed design optimization. And also joining me today is Bart Kanters, President of Concrete Ontario. So Bart, I'll let you introduce yourself.
Great, thanks Alan. Yep, Bart Kanters. I've been with the association for 23 years. I also spent 7 years with a concrete restoration company before joining the association. So I've got some experience both on the association front and the contracting front. And back to you.
Perfect, thank you. Now, before we actually get into the agenda, I'm just going to run through some housekeeping items to make sure everybody's on the same page on how we're going to run things today. So approximately it will be a 45-minute webinar. We will save all questions and answers at the end, just to keep things moving. All participants are muted and will remain that way for the entire webinar. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your question. We'll make sure we address everything at the end. The webinar is being recorded and will be posted on the Concrete Ontario website, along with a copy of the PDF presentation. And that's all going to be followed up on tomorrow morning. An email will be sent with an access link where you can access all that information for review. In terms of the agenda for today, we're going to be covering what are EPDs. It is definitely a very important topic and something that has evolved tremendously over the last few years. We'll look at the history of EPDs in Canada. Then we'll dive into the Ontario Industry Average EPD report, which was finally released back in July. We'll look at the scope. We'll look at how the plant data was collected. We'll also look at how the mixed designs were established. After that, we'll look at the carbon reduction goals aspect. How do you actually set a concrete carbon project budget? What are some challenges with actually setting that budget? And then finally, we'll preview the brand new Concrete Ontario concrete carbon guideline, which will be available in about 4 to 6 weeks. We're just working with a graphic designer to make it all pretty. But let's start things off with environmental product declarations, or EPDs. So I will turn over control to Bart, and he'll get us started.
Okay, so I'm not pretty, just to be clear. So we'll continue on here. So environmental product declarations, we've seen things advance quite a bit. Alan, you might have to give me control.
There we go.
Perfect. So EPDs, environmental product declarations, again, they've been in the industry for quite a while. One of our keys as an industry, both the cement and concrete industry, really is trying to address transparency and being upfront about what our environmental impacts are. We fully recognize the fact that if you want to improve something, you have to start measuring it. So really what we see, the big value to EPDs is providing a baseline for discussions. So in the ready-mix concrete industry, we often focus on things like early strength development, strength, durability, long-term concrete performance. And really the last 5 to 6 years, we're seeing more and more discussions about sustainability. So again, it's a new topic. We need to have new tools to be able to quantify it and show improvements and work together with the design community and the contractors to provide performance. So looking at it again, using the simple example here of nutrition labels, basically what we're trying to do is we're using the product category rules for ready-mix concrete for North America. We're using a standard template to evaluate the product and then identify what's the various impacts. So again, it's going to be specific to an individual mix design. So again, we have producer members that are producing, for example, type 3 facility-specific EPDs. Since we're the association, our goal is really to address the industry as a whole. So we're looking at Ontario, and the purpose of this report that we're presenting here today is to quantify for Ontario what are the basic impacts. So a little bit different than the individual concrete producer who is our members. The last bullet point's a little bit controversial. So it reads, the most important metric is the global warming potential. Well, that's definitely debatable. If we're watching the news or we're listening to any government discussion, global warming potential is definitely one of the key factors when it comes to dealing with the climate crisis. So again, it's something that people are it's very important, but it's one of the 5 key metrics that we're identifying in our EPD. So again, there's going to be more and more discussion about what are we optimizing for? Is it only global warming potential? But we'll save those discussions for later. So stepping back, the concrete industry and the cement industry in general have been very supportive of the whole quantification process. Again, we're a local material made from local materials using local labor to build our local communities. So again, sustainability is something that is important to us. It's important to everyone that works in the industry. So back in 2017, the Canadian Ready Mix Concrete Association, which is basically a combination of the 7 provincial ready mix concrete associations and the Cement Association of Canada, got together. We hired Athena Materials Institute to come up with our first industry average EPD for ready mix concrete. So because we were combining 7 regional concrete associations, we had data, compressive strength data that varied from 25 MPa to 60 MPa. We have different raw materials that we use to produce concrete in the different provinces. So again, if I pick on Western Canada, they have sulfates in the soil and groundwater that create new challenges for them. So again, there's different concrete performance requirements depending on where you are in the country. We also have different supplementary cementing materials. So in the Ontario marketplace, slag is the primary material because we have a steel industry that's local to Ontario, and we've transitioned away from coal burning for hydro generation a number of years ago. So again, slag's the most common option here in Ontario. But if we go to other provinces, fly ash or the burning of coal is a more common supplementary cementing material. So when we put this first document together back in 2017, because we were doing one document, we had to try and account for the regional differences in one final document. So we had to combine a few things together. So we produced that in 2017. It expired in January 6th of 2022. Starting in 2020, we began pulling the team together to try and prepare some of the information. And again, we saw significant advancements in our raw material supplier side of updating their information. So in 2022, our goal was to produce, instead of one national average, again, at the technical level, we were looking at the differences in the various provinces. There's different compressive strength requirements in building codes as you move from province to province. There's different exposure conditions that have to be dealt with from province to province, and there's different raw material availability. So for our second go around in 2022, we made the decision, instead of just producing one report, we're going to move it to regional reports, and we're going to produce 7 regional reports. So we've got BC, Alberta, Manitoba, Saskatchewan, Ontario, Quebec, and Atlantic provinces. So again, that covers the 7 regional ready-mix concrete associations that we have in Canada, and we allowed each region to come up with their own individual report. So those reports were published at the end of July. We just had a quick update to fix a few typos recently, but they're all available on the ASTM website. And I know Alen has a link to our Ontario one that you can download from your computer right now just by clicking on it, or you can go to our website to pull it down as well too. So we'll get into that in a second. So when it comes to the Ontario report, because we're now breaking it down by region, we had the ability to identify what are the mixes that are most used in each individual region. So for us in Ontario, in working with our technical committee, which Alen chairs and heads up, we identified 20 MPa to 70 MPa concretes as being the compressive strengths that are most used. We also have a few specialty mixes that Alen will talk about a little later in the presentation that we use quite extensively, so we wanted to include those as well. Baselines are set according to Ontario average cement contents and SCMs. So we went back, and again, last time when we did the project, we were averaging, each province or each region pulled the data together, and then we just did a weighted average based on concrete volume. This time, because we're just limiting it to Ontario, we're just doing things that are valid to Ontario. So like I said before, concrete's a local material. So it makes far more sense, and it's far more accurate for us to do these kind of evaluations at the regional level. So that's why we're so excited to see this new report coming out right now. So again, just walking through the basics, what we're providing, the scope for this EPD is basically cradle to gate. So we're taking A1 through A3 and fully analyzing what are the impacts. So again, just shown on the screen, the basic breakdowns. So raw material supply is A1. So again, we've got our sand, stone, cement, chemical admixtures, water. Those are the raw materials that we primarily use for the production of concrete. A2 is transportation. So we've got to get the sandstone, cement admixtures from their point of origin or manufacture to the concrete plant. And we have to account for the environmental impacts of moving those materials. And then A3 is the manufacturing process. So at the concrete plant, depending on what your performance requirements are for the concrete, the producer is going to come up with an individual mix design that'll be used to meet both the hardened and plastic properties that are specified by both the owner and the contractor. So we're going to blend the individual raw materials at the plant. We need to proportion them either by weight or by volume, and then mix them in typically ready mix truck, but also we have wet batch plants and we have volumetric concrete trucks. So there's lots of different options or types of equipment that we can use. So if we go back to a quick graphical look, again, we've got to get those we've got to extract the raw materials. We've got to transport the raw materials after processing to the concrete plant. Then we have to mix the material and get it ready to send out to the job site. So where we draw the cutoff is right at the gate of the concrete plant. So as soon as we've got that 8 or 9 meter truck loaded full of concrete and ready to drive out to the job site, that's where we're ending our capture of what the impacts of that concrete mix design are as we go through this. So to start this off, here in Ontario, we have about 270 concrete plants. So we started off by doing a survey of the concrete plants. We picked 2020 as the production year. Since we started this in 2021, we needed to make things simple, we went for a full year of concrete production. So again, we identified in total 80 facilities that we're going to evaluate. We had criteria, we basically had size criteria. So small plants producing up to 20,000 cubic meters, medium-sized plants producing up to 60,000 cubic meters, and large-sized plants producing over 100,000 cubic meters of concrete a year. We also have some fairly wide changes in geography. So again, we wanted to vary the geographic location of the concrete plants so that we caught plants in Northern Ontario, Eastern Ontario, Southern Ontario, Central Ontario to cover off the area. So we're very pleased to see the support that we got from our industry when it comes to participating in the plant survey. So we had basically 30% of all the plants in the province reporting in. And what we're trying to do is come up with, for the industry average data that we're calculating, we need a theoretical concrete plant that represents the whole province. So we're basically using weighted averages to come up with what are the inputs from the hypothetical Ontario average. The same thing would be done in all the other provinces. So again, whether we're in BC, Alberta, etc., same process of randomly selecting plants, getting feedback, and going through. When we're looking at the plant survey information, again, we're starting off with some fairly simple things. So concrete production. So we've picked 2020 as the base year. So what's the total amount of concrete that was produced by that concrete plant in 2020? And then we go through and we identify all the various inputs. So again, I'm not going to bore you by going through line by line through what's involved, but basically we're looking at what are your electrical inputs? What are your natural gas inputs? If you use fuel oil, what fuel oil was used. Diesel fuel is an important component, obviously, because we use that for mixing. We also use it for transporting the concrete out to the job site, which is not captured in that A1 to A3. But roughly 30% of the diesel fuel that we use in a concrete truck is for mixing the products together, and it's part of the manufacturing process. So that gets captured in here. We produce concrete year round. It goes from minus 35 in the winter to plus 35 in the summer. So again, we've got winter heating, we've got summer cooling. All those things have to be captured. In the province here in Ontario, we have almost 4,000 ready-mix trucks that deliver products out to the Ontario job sites. So again, we've got to service those vehicles. So things like oil and lubricants and grease and vehicle servicing. There's lots of shops at concrete plants to service the equipment. So again, those environmental impacts have to be captured. Water is another key product that we have to quantify. So again, we use 150, 160 liters of water per cubic meter just in the mix design, but then there's also other processed water for dust control that we use at the concrete plant as well, and we have to capture that. We have environmental reporting requirements in the province. So again, when it comes to C of A's for air and noise, we collect information regarding particulate matter, a lot of information that's out there. So this highlights the individual raw materials that we address at the concrete plant when it comes to the energy inputs and some of the pollutants that we have to capture. The other major component is the raw materials themselves. So along with this goes a massive spreadsheet, and we start off with things like cement. So at an individual concrete plant, you may have 2 different cement suppliers. Those cement suppliers are supplying both GU and GUL cement, for example. So again, in the spreadsheet, the producer has to identify for that fiscal year, what's the total amount of GUL that they purchased from cement plant A, and what's the distance from cement plant A to the concrete plant, so we can quantify the transportation component. And we go through for all of your cements, all your supplementary cementing materials, all of your sand, all of your stone. Again, you might have 3 to 5 different sand suppliers that supply sand to the concrete plant. You might have 4 or 5 different coarse aggregate suppliers. So again, because we're going back to a past year, you're able to total up the total amounts of materials that you receive for the whole year, and what's the transportation distance for each of those raw materials. So again, we came up with things, for example, for the Ontario plant, I believe the average cement hauling distance was about 95 kilometers. The average aggregate hauling distance was about 40 kilometers. So again, that's what we're trying to quantify when it comes to the plant data. Then we get into the more technical components. So we've captured the data that comes up with this hypothetical average plant. Now that's half of the battle. Next, we hand it over to Alen to talk about, for the mix designs that we're identifying, how do we deal with collecting that data to quantify our impacts in the EPD. So I'll hand it back over to you, Alen.
Okay, thank you, Bart. And obviously, we're not using that plant data to showcase it to the industry. You know, we do want to look at mix designs. This is exactly what architects need and specifiers need to actually determine what kind of impact mix designs are having. So for this report, we looked at 23 different mix designs, and it was based on the production of the 2021 season, because we did not have to wait for a complete year worth of data. We were able to get averages from a nice little working group. We were able to draft 23 specific mix designs that were fully representative of the Ontario Building Code and CSA A23-1 tables 1 and 2, which are the exposure classes. We looked at different slag replacement levels, anywhere between 0 to 50%. And then we had to establish baselines based on average Ontario slag usage, and also looking at average cement contents through that working group. So the working group had different representatives from different ready-mix producers. They supplied mix designs, which is proprietary information. We looked at all the mix designs. We made sure that all the performance requirements were met for the mixes we were looking at through those cement contents. And then we created an average mix design to put together those 23 mixes. And when we came up with that, what you're going to see in the report is basically tables. So here's an example of a 30 MPa class F1 concrete, which is a 0.50 water cement ratio. And the table shows you different impacts. So you start with your baseline, which is 30 MPa class F1 with 15% slag. All the baseline mixes are still based on type GU usage. We have not completely switched over to Portland limestone cement or type GUL in Ontario yet, which is going to be happening over the next year or so. So all the baselines are still based on type GU information. And then you can see the impact as you increase your slag usage, as you switch to type GUL cement, your impact gets reduced. So a basic 30 MPa concrete class F1 with just type GU has an impact of 329.02 kgs of CO2 per cubic meter. As you increase your slag, you can obviously see that that impact is decreased. And that just showcases the importance of using slag, of using Portland limestone cement, which has a reduction in this report of about 7% compared to type GU. So using the least carbon intensive materials is the way to go, and something that needs to be done on the ready mix side. Now, when I talk about reflecting the Ontario Building Code and class C1, class of exposure mix designs. So here's a mix from the report. It's the 20 MPa with air 0.7 water cement ratio OBC, or Ontario Building Code house walls mix. There's a lot of volumes, obviously still a lot of houses being built. So it's definitely a mix we needed to include as part of this report, not something that was reflected previously in the CRMCA report. And you can see the lowest impact for this mix design would be about 150 kgs of CO2, and it goes all the way up to about 244 with the baseline set in between for this one. Then when we get into the classes of exposures, so here's an example of, for example, class F1, which is used for pool decks, patios, tennis courts, freshwater pools, freshwater control structures. This is directly from CSA 823.1 Table 1. Its impact is anywhere between 197 to 329 kgs of CO2, with the baseline set at about 292. Class C2, again, not reflected in the CRMCA report, used for sidewalks, curbs, gutters, pavements, garage floors. Again, lowest impact you can achieve about 210, and the highest 352. And this is again based on industry average information. There are obviously type 3 verified EPDs that are out there where you can get even a much better performance. But overall, this is a great starting point for Ontario to have these values. Another one here, class C1 exposure, so 35 class C1, bridge decks, parking decks, and ramps with a baseline of about 313 kgs of CO2. And the most important part about this mix design is you have to achieve a performance requirement for rapid chloride permeability, which is less than 1500 coulombs within 91 days. And to achieve that from a mix design perspective, you actually need minimum 25% slag. So if you see any mix designs that do not have at least 25% slag, it is very, very difficult, almost impossible to achieve that coulomb rating, unless you're going to be switching to your type GU BSF, your silica fume mixes. And that is exactly why we had to set the baseline at that value. So 35C1, 25% slag, that is the highest value you're going to see in a report, because that is exactly what is required to achieve that permeability requirement. So a lot of thought went into developing these mix designs, and we definitely have come a very long way compared to the CRMCA report. Now, how far have we come? Here's just a little comparison of some of the benchmark mixes that were used in the CRMCA report in 2017, and then looking at some of the numbers from the Ontario report. You can see there's some drastic reductions in the GWP value. As Bart mentioned, there was a lot of averaging that went on when it came to the CRMCA report, so it's not a complete apples to apples comparison, but overall, it's a pretty good indication of how far our industry has come in just 5 years. So you can see the 40 MPa concrete mix with air, there's a reduction of over 21%. just for that benchmark versus the new benchmark that we set for Ontario. So there's really no greenwashing going on here. We did our best at looking at average SEM values, looking at average cement contents, and really try to set the baselines as accurately as possible to really reflect where our industry is currently. Now, it's going to be very interesting to see where we go in the next 5 years. This report is valid for 5 years, and so are all the other regions. There's a lot of cement industry innovations through the Cement Association of Canada. As I mentioned previously, there will be a complete switch over to type GUL cement in the next year or two, which is drastically going to reduce some of these numbers again. So we have come a very long way. There's still a lot of work to be done. Our ultimate goal is carbon negative concrete or carbon neutral concrete by 2050, which is a global goal. And we will slowly get there by having this transparency available. So having the report developed, having the mix designs, having the baselines available, now we can really get into talking about a carbon reduction, goal setting, talking about how to go through that process. And it all starts just like it did before in specifying the correct concrete. So you will see tables like this in a lot of different projects. You need to indicate as a specifier and as an owner, what are the elements you're going to be pouring, what's the compressive strength associated with those elements, what's the class of exposure that needs to be used? Is it going to be exposed to just freeze-thaw? Is it going to be exposed to chlorides? Is it an internal application where it's not exposed to anything? There's water cement ratios that go along with those classes of exposures, air content categories, air ranges. And then the new component is really going to be these industry baselines. So as an industry, we put a lot of work into achieving these baselines. And this is what we are promoting to specifiers and owners to target in on and set it as a new performance requirement. So you go to the table, you look at, for example, a 25 MPa class F2 mix, you go to table, whatever it is, and you look at what is the baseline for that mix, and you include it as part of your project specifications. So you still have to meet all the performance criteria associated with the class F2 exposure, but now you also have a industry average EPD GWP value that must be met on this project. In terms of setting actual carbon reduction goals, so you do need to use some kind of GWP value so ready-mix producers know what they need to achieve. So we do obviously encourage specifiers to use the Ontario industry average EPD baselines, but it's not required. If you want a much bigger reduction, you can definitely choose other numbers in the tables. But the challenge with using just GWP numbers is they are absolute values. They're very practical for using for concrete that's going to be poured in favorable weather, standard placement methods. Some challenges you will see as soon as you get into cold weather concreting where you are changing the mix design, you're accelerating set, you're accelerating strength development, you're using special applications, for example, like SCC shotcrete. The project schedule is very, very vital and something that needs to be respected. So including, just GWP values as a specifier, you will come across a lot of challenges and problems in actually getting those numbers enforced. And the carbon accounting needs to be more flexible when you are setting those values. There's no plus minus on them, they're absolute values. And that's something that we have looked into and something we are trying to tackle with a guideline, which I will preview a little bit later on. But what we're proposing is setting a concrete carbon project budget. So you have your baselines established as part of your performance requirements. And then what you really need to look at is setting a benchmark for your carbon budget and then looking at the concrete that was actually poured. So how do you go about doing that? So to achieve a carbon reduction, you need a benchmark and you need what was actually poured. So the benchmark represents all the emissions that will be calculated using your volumes for mixes multiplied by the respective GWP Ontario industry average baselines. So that is how you're going to be setting that benchmark. And then the project portion is the actual emissions of the concrete that was poured. Ready-mix producers are going to be optimizing those mix designs, using more slag, using GUL cement, using all sorts of admixtures to reduce their impact even further from the baselines. And then your percent reduction for that project will be that reduction, benchmark minus project, divided by the benchmark times 100. So a little bit complicated, but let me just provide an example and showcase exactly how this works. So let's look at that pool deck that I mentioned previously, class F1 exposure, 30 MPa. The baseline for this mix design from the report is 292.7 kgs of CO2. And we're going to assume that the volume for this particular project was 9 cubic meters. So it's going to take 9 cubic meters to pour that pool deck. You have your baseline from the report. And then I took another number from that report and assumed that, that mix design will be optimized. It will be better than the baseline. And I chose 230.06 kgs of CO2. So to set your initial benchmark, you have to take the anticipated volume of the project, which is 9 cubic meters. You multiply it by the baseline that's given in the Ontario report for the class F1 exposure, and you come up with a benchmark for the project of 2.6 tons of CO2. Now, this is a value you don't want to exceed, and you want to make sure that the mixes are optimized and you're able to stay below this value. Then, when you actually go to pour the concrete and you're optimizing your mix designs, you're including more slag, you're using all those aspects that are able to reduce your CO2 output. And as I mentioned, the mix that would be used for this project, 230.06 kgs of CO2. So you get about a 0.5 ton difference between what was benchmarked and what was actually poured on the project through mix design optimization and using better raw materials. You calculate the percent GHG reduction, and you get about a 19.2% reduction from the baseline for this project. So very, very simple. You establish a benchmark, you start the project, you see exactly what was poured and how mix designs can be optimized. You look at the difference between the two, and you achieve a percent reduction from the Ontario baselines. So that's a very, very simplistic way of looking at it, but there's major, major challenges when it comes to a carbon budget and setting it properly, and then following through the carbon accounting. So one big challenge, obviously, cold weather concreting. In Canada, we have a lot of minus 20 days, minus 25 days. We do require accelerated sets and strength development, and it will impact your carbon budget. So cold weather in Ontario is defined as when there's a probability of the air temperature falling below 5 degrees C within 24 hours of placing. So that's taken directly from CSA A23.1. And additional problems you will have with cold weather concreting, you need additional protection. You need curing. There's a lot of curing challenges. You may need heaters. You need a lot of thermal blankets. And all that additional work and making sure that the concrete will gain strength could have a negative project schedule impact, which is something that is critical to a lot of contractors and owners. So the ready mix industry does have a lot of solutions. There's set accelerated mix designs, there's strength accelerated mix designs. There's a lot we can do to change the properties of that mix design to allow specifiers and contractors to keep their schedule, but that will have a negative impact on the mix designs used because you are getting all those benefits of being able to pour concrete minus 10, minus 20 degree weather. Some other challenges you're going to see with the carbon budget are special applications, SEC, shotcrete. So we do have baselines for these mix designs in the Ontario report. And, you can look at their impact compared to standard mix designs. Now, SEC concrete, self-consolidating concrete, is designed for a lot more than just strength and durability. It's designed for flowability, pumpability, placeability. You need a lot less labor. There's a lot of benefits in using special applications such as self-consolidating concrete. But again, what kind of impact does that have on the GWP value of that mix design? And architectural concrete, I just mentioned some of the benefits already. It's something that architects need and want, something the ready mix industry is able to provide. It is definitely critical. because you can't take a standard mix design and use it the same way as an SEC. But as I already stated, the impact on the overall project budget will be negative. So if you use all available low carbon raw materials, the ready mix producer has the following options to achieve some of these special applications, to achieve some of these cold weather concreting solutions. They have to increase the amount of type GU or GUL used. You're getting better performance in cold weather, which again drives up the CO2 footprint of that mix design. You also may have to reduce the amount of SCMs you're using, so slag primarily in Ontario, to get you that better performance, to get that concrete to set up quicker. You may have to reduce the amount of slag you're using, which again increases your CO2 output of that mix design. So there's definitely challenges in setting a carbon budget, and you can incorporate the use of specialty admixtures again to help you there as well. And that's why exactly we've developed this concrete carbon guideline. So I'm not going to get into exactly how the carbon budget can be changed and fixed to address some of these common problems. We will be releasing this concrete carbon guideline in the next 4 to 6 weeks. And basically, it has a comprehensive look at specifying low carbon concrete through performance-based specifications. It has a compilation of low carbon concrete documents and resources that are available in North America. It looks at things that the Treasury Board of Canada is doing. It looks at specifications that the Biden Clean Act in the US is using. There's a step-by-step process to set a carbon budget and overall carbon accounting procedures. And it does address the impact of cold weather and special applications on a carbon budget. So I built it up a little bit. We do have a solution for everything I talked about, but it is something we're still finalizing, and it is something that's going to be available for a webinar in about 1 month's time. The guideline also has a condo case study, the Met in Vaughan. It's a 35-story condo. There's 30,000 cubic meters of concrete that were poured between 2016 and 2019, and 15,000 cubic meters of the 30,000 were accelerated. And the guideline will go into great depth, looking at how you deal with these accelerated mixed designs and special applications, and how it actually impacts your carbon budget. So that's pretty much all I have today. Bart, we do have several questions that have come in.
Okay. Well, before we get into those,
Yep.
Again, I just wanted to stress from an industry standpoint, what we're providing here are basic tables. So what we've heard loud and clear from owners and the design community and the government is that people want to move to life cycle accounting. They want to know what the carbon impacts of all construction materials are. And really our first primary objective was to produce for the 7 regions in the country. Here's baseline information that can be used. These numbers, again, it's not as simple as going through the 40-page report that we have attached to this presentation here and just picking numbers out of a table. There's a lot more to it than that, and that's what Alan's going to try and touch on in our next presentation. But what we have for you today is basically the industry average information for Ontario. So I think the real benefit to the industry is by having our technical committee work together to come up with what are those real baseline numbers. Again, if I look at something like industrial floor slabs, I think the industrial floor slab number was either 10 or 15% slag. I'd have to go back to the report and look at it. But again, in the winter, that number is very low. In the summer, that number can be very high. But we're looking at what do we typically use over a whole year. So again, trying to factor in the impacts of both hot weather construction and cold weather construction to come up with benchmarks. But ultimately, it's going to get down to now we can have a discussion about this is what the industry is currently doing. We can do better. Let's talk about the implications depending on the construction schedule, depending on the time of year we're actually constructing the concrete. So there's going to be huge opportunities for greater collaboration on this. But again, it requires that collaboration between the architect, the engineer, the owner, the contractor, and the supplier. So I'll leave it at that.
Now, I do see some hands up. We're not going to be opening the lines, but if you do have a question, make sure you use the questions pane on the right side of your screen and just type in your question, and we'll run through some of the questions right now. I guess the first question we have, Bart, is we mentioned that we're primarily using slag in Ontario. The question is, what are some other SCMs that could be used in the future if steel industry decides to get even cleaner and produce less slag? What are some other sources that could be used in the future?
Okay, well, there's a lot of effort currently underway. CSA A3000 is the cement and supplementary cementing materials standard. So again, I think one of the first things that we're seeing a lot of effort going into is the harvesting of fly ash. So there's a lot of landfilled fly ash sources from the last 30 to 40 years, and there's a very significant quantity of fly ash that's just sitting in the landfill as a waste product that can be used by the concrete industry. So there's a lot of efforts being put forward to begin extracting those materials and trying to utilize those. There's other new materials that are being looked at, metakaolin, again, we can go, there's a whole bunch of different clay-based materials that are being looked at, and CSA A3000 is really trying to address how do we quantify the performance of those materials. So again, the key for us in the concrete industry is we're synonymous with durability. So we want durable, long-lasting solutions. We measure the life of our product in decades. So we need long-lasting products. So there's quite a few new and innovative supplementary cementing materials that research has been done. And as we move forward here, quantifying our carbon intensity, there's going to be more effort put into using those new products. So I'll leave it at that.
Okay. I can tackle the next one. How often will the report be updated? So the report is valid for 5 years, but if we do see that, for example, other SCM sources are coming to the market, there's a complete switchover maybe to GUL, and things have significantly improved in the industry, the report can be updated on a yearly basis, every 2 years. It really comes down to collecting the information again and going through the process with Athena. So right now it's valid for 5 years, but if we do see a lot of improvements, the report can be updated in the next couple of years to reflect those things. Yep.
Yeah, and I should highlight again, we really want to thank the National Research Council from a Canadian Ready Mix Concrete Association perspective. They provided funding to the industry to support our efforts. I think we all underestimated how much time it would take to go from one national report to 7 regional reports, but again, the level of detail that's provided in going from 1 report to 7 reports is pretty significant. And again, now that we've gone through this process once, we expect to see some fairly dramatic improvements in some of our raw materials in the coming years. So we're set up to update it at a more frequent basis, but 5 years is the max.
The question is, the next one is pertaining to Type 3 EPDs. What happens if a ready mix producer does not have Type 3 EPDs available? What's I guess the impact of what kind of concrete they can actually supply to a project?
So that's the elephant in the room. Again, we have a number of concrete producers that have Type 3 EPDs. It's been very clear to us over the last couple of years at the association level that the demand for Type 3 products or concrete plant specific EPDs is increasing. Again, it's a chicken and egg kind of thing. I think we're going to see very significant advances forward. Now, one of the key purposes of our regional EPD was to come up with regional benchmarks. So again, all these accounting systems rely on trying to come up with a reasonable benchmark that can be used to evaluate performance on the project. So that's really what your next presentation is going to cover off, going through an actual case study showing how we use this. But again, I think one of the biggest things that we get from this report is identifying benchmarks for the 7 regions so that we can start the discussions about on average, this is where a project typically would fit in. How can we improve on that and push the discussion along those lines?
Okay, thank you, Bart. Who is leading the charge in asking for EPDs?
Well, either one of us can answer. I'll let you go with that one first.
Well, I think you're sitting on the Treasury Board committee, so I think that's really what it comes down to.
Yeah, so the Canadian Ready Mix Concrete Association's been in discussions with Federal Treasury Board for 2 years, along with the Cement Association of Canada, on how much more we could do in the industry. Again, we recognize that concrete is the most used construction material in the world, and it's the most used construction material in Canada. So again, here in the Ontario marketplace, we're 11.5 million cubic meters of ready-mix concrete that gets produced. And then you've got precast concrete and masonry concrete and interlocking paver concrete, concrete pipe. There's tons of other concrete products out there. So again, it's the fact that it has strength, it has durability, it has resiliency, and it's local. It's why it's used so extensively. And really what we've seen the government pushing on us is to quantify our improvements. So again, you showed the slide showing anywhere from 15 to 23% improvements from 2017 to now. And I know it's a little different because it's national averages versus Ontario. But again, we've seen dramatic improvements in the raw materials that we use. And we're seeing, again, a lot of focus on what can we do at the plant level to optimize our concrete production processes to minimize carbon. So again, a lot more discussions going on in this in the last 2 to 3 years.
Okay. The next question pertains to the benchmarks that were set. So this person's understanding is that 50% of the producers will exceed the benchmark values and 50% will be below the benchmark values. So the question is, if we are trying to reduce the carbon footprint, would it be unreasonable to specify a benchmark of less than the benchmark so that every supplier and bidder is stretching to achieve the highest possible carbon reduction?
So it's interesting question. So it's not just 50% are above and 50% are below based on mix design. It's also based on time of year. So if you want to push people, if you're pushing them in June, July, and August when it's 25 to 30 degrees and you can use some very significant quantities of SCMs without having any set strength development issues, then that's one thing. I guess that's one of the key challenges that we get into here. Ready-mix concrete is really the only construction material that comes out to the job site in an unfinished state. It's literally plastic and it's flowing down the chute into the form. So outdoor weather temperature has a huge impact on our industry. And that's why I made the comment before. You can't just go, okay, if the best number in all these tables is GUL cement with 50% slag, then I'm going to specify GUL cement with 50% slag on every one of my elements on my project. And clap my hands, work's done. Well, there's the constructability issue. Again, we can supply it, but there's the whole constructability issue, contract schedule, time of year, how long is it going to take to gain strength? That's where there's going to have to be a lot more interaction. So again, we didn't want to start off with something ridiculous by just saying, okay, the baseline is the worst possible cement that we can find out there with absolutely zero supplementaries. That's going to be our benchmark, and we're going to start from there because that's ridiculous. That's not what the industry is about. So again, by looking over a fiscal year of production, that you get the hot weather, the cold weather, you get different contractors with accelerated needs. That's really what I liked about the regional approach to this, is that we're going back and asking producers about not the hypothetical, but what they actually produced that previous year. So again, there's a lot more rigor to that than just pulling numbers out of a spreadsheet.
And that's exactly what the case study will showcase on the next webinar. You're going to see what was initially benchmarked and what was anticipated to be used on the project. And then as the schedule actually had a major impact on this project, that more than half of the concrete was actually accelerated, which did change the benchmarks, which did change, again, the baselines. So it's going to be very eye-opening to see how on a complete project actually progresses and what type of mix designs are actually used in the winter and fall months.
Yeah, and I think it's going to be great. Again, our industry is very performance driven. We like performance-based specifications. We've been supporting that for 30 years. And again, we're moving into a new era where we're going to have more discussions, not just about how do I give you early strength? How do I give you low shrinkage? How do I give you low permeability? Now it's going to be how do I give you the lowest carbon intensity and still meet the overall performance goals for the project. So again, I think as an industry, we've stepped up to the plate here, and we're identifying here's our carbon intensity. The purpose of the tables really shows you what's the basic impacts of using different cement types or supplementary cementing materials. But I think as time goes on, you're going to see a push for more type 3 facility specific EPDs of, okay, it's nice that the average cement hauling distance was 94 kilometers, but if your concrete plant is 15 kilometers from the cement plant, that's the number we should be using. Or if it's 150 kilometers from the cement plant, that's the number we should be using. So I think we're starting off here with the industry averages, and the 7 regional concrete associations are providing the baseline numbers to start the discussions. And then the next year and a half to 2 years should be interesting times as we work through how do we best implement this with the goal of having a lower carbon intensity on the final project. That's the real goal.
Mm-hmm. There's also a follow-up question to that question. Will there be a carbon reduction calculator tool in the future, similar to what the Slag Cement Association has provided in the US? So we didn't include as part of this presentation, but go ahead, Bart.
Yep, we're in the process of trying to finalize that right now. Our first step was to, for all 7 regions, take that hypothetical average concrete plant and allow the concrete producers to input their actual mix proportions to come up and see what the impacts are. So again, from an association standpoint, we've developed a calculator as a tool for the concrete producers to see, okay, if I make these changes to my mix design, what impacts does it have on, if we're picking on global warming potential as the primary category, how does it change the global warming potential number? Again, I think ultimately you're still going to have to move to a true type 2 calculator, which is your actual concrete plant data and your actual materials, unverified, or a type 3 calculator, which is a third-party verified tool. But again, we've collected all this new data. We've got the ability to literally in 2 minutes enter in your mix design information and say, okay, if I change the mix in this way, what positive or negative impacts does it have to the project? So that calculator will be rolling out in the next couple of weeks. We'll have it up and running by the time we do our next webinar on carbon accounting.
Okay, I think that's pretty much it for the questions. So thank you very much for your time, Bart. Great discussion today. And again, we will have the next part of this webinar series, which will be on October 26th from 10 to 11 a.m. And it will be all about specifying low carbon concrete. So we will look at the guideline. The guideline should be available by that date. It will be shared with everybody on the webinar. And we'll make sure to cover off some of that teasing that I did by looking at special applications, looking at cold weather, and really looking at how a project schedule can change a carbon budget. And goals need to be set realistically, because if you're setting goals too high in the beginning, it may be very difficult to achieve if you are trying to achieve a specific project schedule. So Bart, anything else to add here before we wrap up?
No, again, we just want to thank both the Athena Materials Institute for working with us literally over the last 12 months to pull this together, and for all the support that we got from the National Research Council of Canada in supporting this project, because we've learned a lot and we've brought the industry forward quite a bit, and we've got much more accurate data to supply to all 7 regions in the country. So thank you.
Okay. So again, thank you very much for everybody for tuning in today. The follow-up email will go out tomorrow. It will have a link to the recorded presentation, to a PDF copy of this presentation, and we'll also have a registration link for the October 26th webinar. So again, thank you very much for your time, and hopefully we see everybody on October 26th for a follow-up discussion. Have a good day.